All right, let's move on to a new topic. And this is a little bit unusual for us. All right, now in this particular situation, we still have our electric field as shown by the red lines right here. Now, in this electric field, instead of just placing one single charge, and then having the field tug on it, typically positives go with the field lines, negative charges go against them. All right, let's take a look at a situation where we have a dumbbell. A dipole. So a dipole basically is a situation where we have a positive on one end and a negative on the other. And they're fixed so that they rotate kind of together in one line. So I've tried to draw a picture of one right here, positive on this side and then negative on this side. And they're attached. If we're talking about dipoles and molecules or whatever, it's usually bonds or something. If it was a weightlifting contest, you would have a weight on either end of the dumbbell, and then you'd end up lifting them up. So these two are kind of stuck together in the sense that when one moves, it also affects the movement of the other one. Now, there's a center point of rotation here at this point, and we're going to define the distance from the positive to the center as x. And then we're going to define the entire distance, d, that's the distance between the positive and the negative charges at either end of that dumbbell, at that dipole itself. So these are our definitions. Now, if I look at this and we take a look at the forces, what direction are the forces? Well, we notice that we have a positive here in the electric field. Don't positives want to go in the same direction as the field? So the force acting on the top one, and it actually goes to the right in the same direction as the electric field lines. What direction are the forces on the negative? Negatives want to go against the field lines, so the force acting on the bottom one looks like this. All right, now, if we take a look at these two forces, the force pulling on the top this way and the force pulling this way, there's a tendency for this dipole to actually twist and then turn and then actually rotate due to the fact that the forces are pulling in opposite directions. So I expect this dumbbell at some point in time to actually level itself out in the electric field and then kind of work its way parallel so that the forces align here. So just picture what's happening in the very top. When this force pushes this way, it pushes this down. In the bottom here, this one pushes this way and rotates it. So we end up with this rotation, something along these lines right here.